Hi guys, it's Mrs. Millis again. Let's talk about geometric distributions, and we already really know how to do geometric distributions, but I want to show you a couple shortcuts in the calculator. Okay, again, we're going to do the probability that somebody likes chicken. All right, a geometric distribution is very similar to a binomial, but we don't have a set number of people. Like in the binomial, we had, 50 people and 100 people out of 100 people out of 150 people. But here we're concerned more with when's the first time I'm going to see somebody that likes chicken. So if I say if I ask for what's the probability that the first person I ask likes chicken, we know that that's, again, it's just 0.7 to the first power, because that's the first, first one person's either just going to like chicken or not, okay? So that's the probability that x equals 1. What if I say, what's the probability that the second person I meet is going to like chicken, okay? Well, if the second person likes chicken, the first person doesn't. So there's the probability that the first person doesn't like chicken times the probability of the second person liking chicken. And again, you're thinking, well, this is just a tree, okay? And you're absolutely right. Here's the first person not liking chicken, second person liking chicken. But it's just a specific subset of the tree. So if I say, what's the probability that the third person likes chicken? Of course, the first two people don't like chicken, and then the third one does like chicken, okay? And I can keep going. I can say, what's the probability that the 10th person likes chicken, which means the first 9 people didn't, and the 10th person liked chicken, okay? So I can do all these probabilities. This is very straightforward, okay? It's just a tree, an independent tree, and it's just a single branch, okay? Now, I can do these as a little shortcut, okay? I'm going to write down these probabilities. Of course, this is 0.21, this is 0.063, and this is very small, 4138, okay? But I can also use a geometric distribution in my calculator to do this a little faster. Not that this isn't fast. I would totally do this, okay? I wouldn't even worry about the geometric PDF, but I'm going to show it to you anyway. So there is a formula, okay, when probability of x equals k, so these were my k's, I simply take 1 minus the probability and raise it to the k minus 1 power, right? So when k was 10, I raised it to the 9th power. And then I multiplied it by the probability, because that will always be raised to the first power, okay? Again, just be familiar with that equation. This is this, okay? But I can also do this in my calculator with Geometric PDF, okay? Same place, normal CDF and binomial PDF and CDF are, okay? Second vars, second distribute. Now you can scroll down, but it's so far down on the second page, I scroll up, and it's at the bottom of the second page. So if you scroll up, you get there faster. So, darn it, the sun's causing a glare. All right, hopefully our glare is not too bad. So now, again, I don't have an n. I don't have to worry about the total number of trials, because there's no total number of trials. But I do have to put my probability of success. And this is the x value of where I want my first success to be. So we'll do this one first. I want my first success to be on the second person, okay? So you notice that that is the same thing, okay? So geometric PDF of 0.72 is the exact same thing. If I come up here and change this to a 3, this would be the third person is the first success. And again, it's the exact same thing. Okay, first person to like chicken. And then we'll do the 10th person. And it's the exact same thing. Times 10 to the negative 5th, so 1, 2, 3, 4, 5. Yep, same thing. Okay, so again, I wouldn't get bogged down with this, because I would think through the branch of the tree. First person doesn't like chicken, second person does. First 2 people don't like chicken, third person does. First 9 people don't like chicken, 10th person does, okay? So this is just probability in x, okay? But where this comes in handy is when we want to do cumulative. So let's change from, we'll do our chicken. Let's say, what's the probability? I have to ask at most 3 people, okay? I have to ask at most 3 people before I find someone who likes chicken, okay? All right, so I have to ask at most 3 people. So really, I would add these up. Okay, this of course is 0.7. Okay, I would add these up because at most 3 would be 1, 2, or 3 people. Okay, so I can add those up. I mean, they're right in front of me. Okay, so if I add up the probability of 1, 2, and 3, I get 0.973. But I can also use Geometric Cdf, just like I used in binomial. And Geometric Cdf does the same thing. It accumulates from the left. So of course I'd put my probability. And I want, let me draw a little thing here. I'm going to go from one person to whatever. So I have 3. So at most 3, I know is going to be, it's going to accumulate the probabilities for the third person liking chicken, the second person liking chicken, and the first person liking chicken. Okay, so I'm going to put 3 as my X value because it's going to accumulate from X down, and it's the exact same thing. Okay, and I can do an at least. Okay, what's the probability that at least I have to ask at least 4 people? Okay, before I find somebody that likes chicken. Okay, so if I go from 1 to whatever, because it's endless, at least 4 would be 4, 5, 6, 7. You know, I have to ask those many people before I find somebody that likes chicken. I will use my cumulative CDF the same way because I first of all, I can't even calculate. I could do, you know, probability 4, probability 5, probability the 6th person, 7th person, 8th person liking chicken. But this is endless. This goes on forever. It could be the 100th person, the 101th person, the 1000th person, and I'm not going to calculate all those. So I'm going to do my 1 minus Geometric Cdf, so again, cumulative. So again, all these probabilities equal 1, but I'm going to subtract from here back, and it should get me everything out. So if that's 4, that's got to be 3. So I'll say 0.73. So I'm actually going to subtract that accumulation, okay, just coincidentally. I should just come up here and do this. Do 1 minus. Okay, so that would be 0.027, okay? And again, you know, these are small numbers of people. I could probably have, you know, calculated the 3, which I did, and done 1 minus. I would have gotten the same thing. But where this comes in handy, where the use of these equations come in handy, well, really the CDF, I very rarely use the PDF, is when we have a larger distribution. So let's say, I'm going to use a different scenario. Just Googled, there's 2% of the population has red hair. So the probability that somebody will have red hair is 0.02. Okay, so what's the probability that the 8th person I see has red hair? Okay, so the probability that the 8th person has red hair. Well, if the 8th person has red hair, that means the 7 in front of them did not have red hair. So I can just 0.98 to the 7th power times 0.02, because those are my 7 people that didn't have red hair, and that's the 8th person that did. Okay, so if I do that, oops. Sorry guys. I get 0.0174, okay? And that's exactly how I do it. If I wanted to do my geometric PDF, I could. Geometric PDF, probability of success having red hair. I'm concerned with the 8th person, so I'll put 8 in here. And it's going to be the exact same thing, okay? So again, I tend not to use a PDF. I just think of the tree. 7 people don't have red hair, the 8th person has red hair, okay? All right, but where this will come in handy is if I want to know what's the probability that I have to ask at most 10 people before I find somebody with red hair. Okay, so I have to ask at most 10 people. So I've got 1 to whatever, and there's my 10. So at most 10, so I could ask 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, okay? So I'm going to use my Geometric CDF To accumulate the probabilities of asking 10 people, the 10th person has red hair, which means the nine do not. The 9th person has red hair, which means the first 8 do not. The 8th person has red hair, which means the first 7 do not. So that would it would take a long time, okay? Not that it's undoable, but this is a lot faster. So here, I would do Geometric Cdf again, the probability of red hair. And my x value that I'm going to accumulate from and to the left. So I would put 10. Okay. So there is a 0.1829 probability that I have to ask at most 10 people. Okay. So this was a lot faster than having to do this for 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1 and adding them all together. I'd rather do that a lot faster. Okay. And then let's do the probability that I have to ask at least 5 people before I find someone that has red hair, okay? So at least 5, so I have one person to whatever. So at least 5 means I'm gonna have to ask 5 or more, 5, 6, 7, 8, 9, or 10 people before I find somebody that has red hair. So since I want a total to the right, I'm going to do my 1 minus my accumulation of the left, okay? Because again, all these probabilities will add up to be 1, but I'm going to subtract this part to the left, and if that's 5, then I got to accumulate from 4 back, from 4 to the left, okay? Not that I couldn't calculate the 4th, the 3rd, the 2nd, and the 1st person having red hair, add those up and subtract those from 1. I could, okay? I'd get the same thing, but this is a lot faster, okay? Let's see, 1 minus. So I want the 4th. Okay, so this would be 0.922. Okay, 0.9224. Okay, so it's about a 92% chance that I'm going to have to ask at least 5 people. Okay, pretty high probability I'm going to have to ask at least 5 people. Okay, before I find somebody that has red hair. Okay. So again, these are nice and fast when you're using a cumulative, okay, when you're trying to find at most or at least. But when you're just trying to find an individual, just think of the trait. If the 8th person has red hair, it means the first 7 people didn't, okay? So I think that's a lot faster than having to do with that, okay? Now, if you use these, because you'll probably use these on the AP test, you have to identify what these things mean, okay? So I would just, and if you do it, if there's multiple questions of the same situation, you only have to identify it once. So I would just come up here and I would say probability of red hair. That way, anytime you reference 0.02, they know what the probability, they know what that is, okay? If you write that out, you don't need to identify anything, okay? AP readers just don't like what they call calculator ease, okay? If you're just running stuff in the calculator, okay? Okay, I think that is it for geometric. So geometric really, it's just a specific branch of the tree. It's just the specific branch of the tree, okay? But the Geometric Cdf is very helpful in the calculator when you have to accumulate from a point to the left or from a point to the right. Okay. All right, I hope this was helpful, and I'll see you later.